Okay, so given all that, let's say we've made our simulation and we're running it. What can we actually expect to get out of this? And this is kind of like a large question because, I mean, in general, depending on on the simulation and on how detailed you have made the simulation, you can get a full account of the events that that occur in the network. What and when did photon A arrive at location B at time C, and in general, there will be a lot of sort of different things that happen in a network. And at least the Aliro simulator, we use sort of an event framework where events lead to more events, and we can get a full account of what's happening across time in the network, down to the level of detail that we have provided, of course. So yeah, in general, you can gain any information that you want as long as you put in enough detail, and also be able to run it enough times. Sometimes there's some probabilities in simulation, and so running it once may not produce the same result as the second time. There's like some stochasticity in there, and so you need to often run several times in order to gain statistics on how well your network is running on average. You'll need to gain averages. Generally, though, that said, the most useful information to glean from simulation is generally how well your network works. What is its performance? This can come in many forms, depending on what you actually are looking at and care about. But in general, often performance comes in the form of a rate and a fidelity of a given quantum link, or multiple rates and fidelities across multiple links, for example. So just to explain the rate and fidelity, as an example of a performance metric. Say a link is distributing entanglement, then the performance of that will be given by the rate, which is just the average number of entangled qubits that are distributed per time. Sometimes that can vary, so you might want to take an average of how many pairs per second or whatever you can get between nodes A and B. And lastly, the fidelity of those pairs, the average fidelity of those pairs, is also important, because this kind of tells you how good the entanglement is that you have actually distributed, right? A fidelity of 1 means it's perfect entanglement. A fidelity of 0 means that it's not even close at all. In general, you want a fidelity that is, it depends, right? Because the lower the fidelity, the more chance that your entanglement isn't going to work for what you want it to work for. And so if you don't care that it doesn't work half the time based on your application, then you can have a lower fidelity. But if, for example, in a security application, you really want to have a pretty high confidence that you have entanglement, then you might need to optimize more for fidelity than you do rate, for example.